Right, so we're now going to look at a set of operators that are known as the logical operators. So they obey certain types of logic. There are three operators that we're going to look at here. One is done with the exclamation mark. The next one is the ampersand, double ampersand, and the next one is done with this key here. I'll come back to that in a moment. Firstly, the exclamation mark is known as the not, okay, or the negation operator. The next one is the and operator. So we see two ampersands there for that. And the next one is the or, which is these two lines. Now on the keyboard they're down beside the shift key on the left, and so they're between the shift key and the Z key, just above, on the same key as the backslash, so you should find it there on your own keyboard, and you need to do two of those for the or. This negation one or not is a unary operator, and that means that it operates on only one variable, whereas the other two operate on two. You'll see what I mean by that in a moment when I give an example. So let's take the x here. If I put the not in front of that, what occurs is that the x is evaluated first, and x is a value of 3, which is non-zero, which means it's true. So what we do is we put the negation in front of that, and that will make it false. It will do the exact opposite. So in this case, the overall extent of that will become false, and that is indeed the case because the hello is not happened. Now let's try it with a situation where we put a 0 in here, which of course 0 is considered false, but we do the not of that, which is considered then true, and we run that and we see the hello comes up. Okay, so therefore this has become true and it has operated this section of the code. Okay, so that's the not or negation operator. And when I said earlier that that was a unary operator, it operates on only one variable. We can see only one variable name here. What I'm going to do though is I'm going to add another variable here. You've probably realized at this stage that you can put in a second variable by doing that, but I'm not particularly a fan of that, so I'm going to put it here. And I'm not a fan of it because it's not quite as neat, and it doesn't mean I prefer to have every variable have a line of its own so that you can write a comment after it if needs be. Right, we're going to put some values into these. I'm going to put y is assigned a value of 3, and I'm going to put x to be a value of 5. No particular reason for that, just pick any values that we have. So x here, we'll say if x is equal to 5, which as you can see it is, I'm going to use the ampersand here, the and one, and I'm going to say y greater than or equal to 0. Okay. Now, I think you'll agree that x is indeed equal to 5. Y is also true here. Y is greater than or equal to 0, because it's a value of 3. Now the way the AND works is very much like if you've done any digital electronics, it works like an AND gate. If you're doing the embedded programming subject with Fergal, he'll probably be going through the gates and the truth tables with you, so it works in the exact same way. Both of these must be true in order for the overall thing to be true. Okay, and in this case both of them are true, so therefore we expect the overall thing to be true and this to get executed. There we go. Hello, up it comes, so it did indeed get executed. Let's put one of these to not be true. So I'm going to say if y is greater than or equal to 7, which of course is not in this case, so that's going to be false, this is going to be true. What happens? Well, they both need to be true, and they're not, so therefore the overall thing is not true, and therefore the hello doesn't get printed. Let's try the opposite one. I'm going to try this being true, and this one being false by putting it to a value of 3. And we can see there again, because one of them is false, the overall thing is false, so that's no good. I'm going to put them both as false, and fairly obvious here, if they're both false, the overall thing is false, and therefore it doesn't happen. Okay, so the thing doesn't get printed. Now, let's try the OR. And the OR works in such a way that we only need either one or the other or both to be true. It's only in a situation where they're both false that it won't work. So I'll go back to the situation where they're both true here so that we do it in the same order. I'll put that to 0. So they're both true in this case. X is definitely equal to 5. Y is greater than or equal to 0. So that's true. And out comes the hello. So that's fine. Let's try it with this one here being false. I'm going to put that to 7. And we can see that it's still true overall because at least one of them is true, and this is an OR, so that's true or that's true. Okay, so either that's true or that's true, and if either one of them is true, then we're fine. And we'll just, to prove that, we'll just put the other one. So we'll put that to true and this one to false this time, and we'll see that it still comes out as true overall. And there we have it. Okay. Finally, what happens if they're both false? So we'll do that here. But if they're both false, then all bets are off. Nothing happens because they're both false. The overall thing is false, and that's the way it is. Okay. You can actually you can include more of these as well. You could put another and in and do another one. It could be y smaller than 6 or something like that. Okay. And this just gets more complex as we go. Where, let's say, I'll put these in brackets here just to make sure that these get executed first. So this is a complex example here. So y is greater than or equal to 5. I'm going to put that to something that's true just to show it to you here. So 0. So y is greater than or equal to 0. So that's true. Y is smaller than 6. Well, it's 3, so it is smaller than 6. So that's true. So the overall thing here, both of these are true, and it's an AND statement, so all of that is true. X is equal to 2. That's not true. Okay, so that's a false. But because there's an OR in between them, we only need one of them to be true. This one is true, so therefore that'll operate. Okay, so this is just like in digital electronics where you can have ANDs and ORs all together, and it's the overall equating of them that's going to matter. Okay. So that's the relational operators, and as you can see, they've a very strong link to what we do in electronics, so we'll be using them a lot.